So this video is going to help you understand decimal place value. You are probably going to want to take some notes on this. So what I would suggest is if you're taking this in virtual class with Miss Higby, that you just watch it through the first time and then watch it again later and slow it down, write down the vocabulary words, and make sure you understand each part of the PowerPoint. So first we're going to talk about some vocabulary words. You should have heard these words before in the past, so this part should be a review. So the word standard form. The definition I got straight from your textbook says, a common way of writing a number with commas separating groups of 3 digits starting from the right. Taking that and kind of paring it down into kid words, it's the regular way of writing numbers with digits. So these are all standard form. It's what we normally think of when we are thinking of numbers. Word form, well, it kind of says the definition within the word. Okay, a way to write a number using words. So I would write 128 as 128. Expanded form. Expanded means that I'm taking something and I'm expanding it. I'm increasing it. Okay. I'm not increasing the number, but what I'm really doing is I'm taking that number and breaking it apart. So it says a way to write a number that shows the place value of each digit. The key word there is place value. Every digit has its own place value. And when I write expanded form, I'm writing those digits within its own place value. So 128 in expanded form is 100 plus 20 plus 8. I broke that down. So this digit has its own place value of 100. This digit has its own place value of 20. This digit has its own place value of 8. And so in expanded form, we break them down into its individual place values. Expanded notation is pretty much the same thing as expanded form, only instead of just writing it in its place value, we're writing it within, it kind of sorta is like PEMDAS. Okay, so a way of writing numbers based off of their place value by using PEMDAS. So look at this, 128 again. 1 times 100. Okay, I'm writing that because the 1 is the digit. So see that? So I have a 1, a 2, and an 8. I have a 1, a 2, and an 8. Okay, so then I write the place value. So the 1 is in the hundred spot. The 2 is in the tens spot. The 8 is in the ones spot. Okay, so then 1 times 100 is 100, 2 times 10 is 20, and 8 times 1 is 8. So if I put them together, I get 128. Then we also have what's called equivalent decimals. Okay, equa. We talked about this word last week. Equa is equal. Okay, so equivalent decimals are decimals that name the same amount. 2 and 8/10 is equal to 2 and 80/100 and equal to 2.8. I don't even know the name of this. Okay, but I wrote that to show you. Notice this 0 comes after the 8. I don't have to have this 0. Okay, this 0 does not have a value. The only reason this 0 is here is to tell me that there are no digits in the hundredths place. Okay, so if I take this 0 out, it's the same as 2 and 8/10. Now, if I have this 0 before the 8, then that changes my value. Okay, so it has to be after. If there's nothing after this 0, then I can take this 0 away. Same thing over here. I can sit here and I can write zeros forever and ever and ever and ever and ever. And as long as there's no other digit, it's just zeros, then these zeros don't count. They don't change the value. So I can say that 2 and 8/10 is equal to 2 and 80/100 and whatever this number is called. Okay? Remember, infinity means numbers go on forever. So I could literally put zeros forever, and it would not change this value. All right, so now I'm going to show you how to take some different forms of numbers and change them into standard form. Remember that standard form is like our regular way of writing numbers, okay, with digits. So I put the hardest one first. This is an expanded notation. Well, guys, I don't want you to think about the whole thing all at once because sometimes we look at that and we go, oh my gosh, Miss Higby, what are you doing to me? Okay, think about it in pieces. What is 6 times 1? 6. 6 times 1/10, well, 6 times 1, again, is 6, right? So it's 6/10. 3 times 1 is 3, so that's 3/100. 7 times 1 is 7, so it's 7/1000. Okay, and this is what that looks like. 6 times 1 is 6. This 1/10, this is the 10th place, so it's 6/10. The 3 is in the hundredths place. This is tenths, this is hundredths. And the 7 is in the thousandths place. Tenths, hundredths, thousandths. So if I put it together, this number is 6 and 637 thousandths. My next number, 4 and 68 hundredths. Now, I drew a multiplication, or not multiplication, a place value chart, okay? So here's ones, you know the ones place, that's the whole numbers, okay? Then we have tenths, hundredths, thousandths, okay? There is no place called once, okay? A lot of students struggle with the concept of right here next to this is tenths. There is no once, all right? Because if I take one whole, there is no way to take one whole pizza and cut it up one time. Because if I cut it up one time, then that's one whole. Okay? So there's no once. It's tenths, hundredths, thousandths. Now, when I have a word form and I'm putting it into standard form, I always want to look for this word and. Okay? And is the key word that I have a decimal. So everything on the left side of and is a whole number. Everything on the right side of and is a decimal. So I first want to deal with anything that's a whole number first. Well, that would be 4. There's a 4 in the ones place. Okay? The and is telling me there's a decimal right here. So then I want to think about this number. I see the number 68. So I know that's a 6 and an 8. What I need to look at next is this word. THS. Okay? Notice THS, THS, THS. Okay? If you see THS, that means it's a decimal. Okay? If I didn't have the THS and I just had the word 100, that would be in the whole numbers over here. Okay? So I know it's 68 and I know that the 8 has to be in the hundredths spot. So if the 8 is here, then the 6 is here. So like this, 68 hundredths. Now, it's okay that there's no thousandths here. I was just showing you the place value chart. Okay, so if I put it together, my 4 and 68 hundredths. Okay, and now I want to take an expanded form and change it into standard form. Okay? If I wanted to, I could take these and write this as a vertical problem and just add them all up. Okay? I could do that. 9,000 plus 40 right here. Okay? Or what I like to do is break up the whole numbers and the decimals and only focus on those, instead of the whole problem. So I know that these two are whole numbers, which is 9,400. Okay? And then if I think about this, I see a 1 in the tenths place and an 8 in the thousandths place, but there's nothing for this hundredths place. So that would be like 108 thousandths, like this. Okay? Notice tenths place, and then this tenths, hundredths, thousandths. Okay? But there was not a hundredths place between them, so that's why this 0 is here. So then we want to talk about equivalent decimals. Well, remember, equivalent decimals are decimals that are equal, okay? Pardon me. So we normally we think of equivalent decimals as 0. If I add a 0 after this 1 in the tenth spot, then I'm not changing the value, okay? I change what it's called, okay? So I usually explain this to kids. Think about me and what you call me, okay? I have different names, all right? So for instance, you call me Mrs. Higby, okay? Does my dad call me Mrs. Higby? No, of course not. He calls me Rachel, okay? Do my nieces and nephews call me Mrs. Higby? No, they call me Aunt Rachel, okay? Does my husband call me Mrs. Higby? No, he calls me Rachel, okay? So I have different names, okay? But I'm still the same person. Think about that with numbers. Numbers, this value can have many different names, but the value stays the same. Okay? So 8 and 1/10, I need a equivalent decimal. Well, I can add a 0. I can add a million zeros after this 1, and as long as it's just a 0 and not another digit, I am not changing the value of this number. I can add another 0 again. Okay? So my 3 equivalent, well, they're asking for 2, but this was my original number. 8 and 1/10, 8 and 10 hundredths, 8 and 100 thousandths. These are all equivalent decimals. And our final problem that we're going to look at, write 2 equivalent decimals for the number. Oh, look at this. Okay? This would be 2 and 2,010 thousandths. Okay, which you won't do 10 thousandths until like junior high. All right, but that's what this name is. Now, I could sit here and add more zeros after. I could add another 0 and another 0 and continue. Or, thinking about it this way, do these zeros change the value of these digits? No, they do not. If I had another digit that was not a 0, then that would change my value. But I could add zeros forever and ever and ever, and it still would not change the 2 and 2/10 value. So I can take this 0 away, and notice now I only have 2 zeros instead of 3. I could take this 0 away, okay, and now I'm down to this one. I only have 1 0. And I could take that 0 away, and I could have just 2 and 2/10. Okay, so all of these numbers are equivalent decimals.